All right. Hi, thank you so much for attending our presentation today. So our group is CH4, and we are going to be talking about air pollution control for industrial breweries. So as a roadmap, we're going to begin with the background, and then after that, talk about facilities and processes, then emissions, then health and environmental effects, control techniques, regulations, broader impact, and then finally the conclusion. So starting off with the background. So the beer production industry has completely transformed the alcoholic market over the past 2 decades. Beer production was once a niche hobby, but has now transitioned to one of the fastest growing segments of alcoholic beverages in the US. There's been a 300% increase in brewery industry size since 2005, and the industry now has a market size in the US of $100.2 billion. The number of breweries has grown from 49 in 1983 to 13,380 in 2021. So breweries have directly employed 70,000 brewers and indirectly employed 2.1 million jobs. So overall, the beer industry contributes nearly $328.4 billion in economic input, equivalent to about 1.6% of the US GDP. So because of the aggressive growth of the beer production industry, there has now been an increase in emission dispersions that have both an impact to the environment and human welfare. Excessive energy usage, large carbon footprints, and high emission levels have labeled the specific industry necessary to identify these emission issues and current regulations and health impacts. So by developing control techniques in the brewing process, reduction of harmful emissions from energy consumption and processing could be a favorable result and alleviate threat.
Okay, so I will be talking about the facilities and processes. During this, I will just be discussing how beer is made. So beer is made in 4 main ingredients and produced in 8 stages. Typically, the beverage includes water, grain, hops, and yeast. The production process can then be broken up into malting, milling, mashing, boiling, initial fermentation, secondary fermentation, pasteurization, and packaging. Malting, milling, and mashing can be summarized as the grain is soaked, dried, ground up into a desired consistency, and then mixed again with water. This last step results in a mix that is then separated into 2 portions, an aqueous portion and a solid portion. The aqueous portion is known as wort, and this will become the base of the brew. The solid residuals are known as spent grain, and these are often sent off to farmers to use as feed or compost. Next, the wort, which is the base of the brew, is boiled for about an hour. Once boiled, the wort is allowed to cool and yeast is added to begin the initial fermentation. Fermentation is an exothermic process, and once the brew heats up by about 5 degrees Celsius, part of the yeast is removed. The brew then goes into a different container to go into the secondary fermentation cycle. This cycle can take anywhere between hours or weeks. Last, all is to do is to pasteurize and package. During this process, though, a lot of emissions are released. The 3 main ones that we'll be discussing are particulate matter, volatile organic compounds, and carbon dioxide. The particulate matter can be found at any step in which the grain is being handled or crushed, because then it gets into the air. For the volatile organic compounds, these can be found at any step, well, almost every step of the process. This is because a lot of different chemical reactions take place during the brewing, which can result in some excess and unwanted gases. Additionally, cleaning solvents and solutions can give off these gases too, which make the VOCs even more present during brewing. Lastly, of course, is carbon dioxide. This makes sense because beer is carbonated. Sometimes, however, there can be too much carbonation, which can be a bad thing when the employees and the environment are exposed to too much.
Now I'll discuss the health and environmental effects of those said emissions. So the effect of beer production on air quality is largely due to the brewing process being energy intensive. Energy consumption is directly correlated with CO2 emissions. Oceans take in atmospheric CO2, which leads to oxygen depletion and reduction in pH levels. Moving to the carbon dioxide effects on health, exposure to CO2 can act as a stimulant and depressant on the central nervous system, leading to a range of health effects depending on exposure concentration. At low concentrations, effects vary from headaches to shortness of breath, and at high concentrations, effects even lead to coma and death. Using 2020 measures, it is calculated that every 1,276 metric tons causes 0.29 excess deaths. That is, the lifetime emissions of 3.5 average Americans causes one premature death. The mortality cost results in about $258 per metric ton of CO2 emitted. Just in the state of Oregon, the beer industry emits over 200,000 metric tons of CO2 annually. Therefore, the mortality cost in Oregon alone from CO2 brewery emissions is approximately 46 premature deaths and $52.3 million annually. Besides carbon dioxide, volatile organic compounds also have damaging impacts on the environment. VOCs contribute to accelerated degradation of buildings and temperature increases by the formation of ozone. So by increasing the concentration of ozone, VOCs are also a contributor to climate change. The effects from direct exposure to volatile organic compounds can also be devastating. They include eye, nose, and throat irritation, headaches, nausea, and even liver, kidney, and central nervous system damage. For particulate matter, the size of the particle is directly linked to its damage potential. Particles less than 10 micrometers in diameter pose the greatest threat, as they can get deep into lungs and bloodstream, possibly resulting in premature death. Control of the air pollutant emissions is best for public welfare, reducing the mortality cost and environmental protection.
So the breweries that we decided to focus on in analyzing control techniques for are the Anheuser-Busch breweries. We wanted to look at larger breweries since they tend to have more control devices. They have 31 breweries all over the world and produce around 11 billion bottles of beer each year. Anheuser-Busch has 12 breweries spread out across the United States. The breweries that we decided to focus on specifically are the ones in Jacksonville, Florida, Merrimack, New Hampshire, and Williamsburg, Virginia. The first brewery we'll talk about is in Jacksonville, Florida. Within this facility, most of the control devices used are focused on PM. Particulate emissions from grain handling operations are controlled by the two dust collection systems, both of which are equipped with bag filters. To deal with CO2 emissions, the carbon from the fermentation process is put through an activated carbon filter, collected, compressed, and then reused to make carbonated water for their light beers. The next brewery we looked at was in Merrimack, New Hampshire. This brewery behaves relatively similar to the one in Jacksonville. To control PM at this location, Anheuser-Busch uses multiple baghouses to continuously collect PM throughout the entire brewing process. The process steam for the brewery comes from two low NOx boilers. The brewery uses what they call a bioenergy recovery system, or BEARS for short, to beneficially reuse the biogas produced from their processed wastewater to be combusted in the boilers. Biogas flares are used to control for excess biogas when there's an increased production or issues with the usage of biogas. The byproducts of the gas from this system are collected and treated using a scrubber, primarily for hydrogen sulfide prior to its release into the atmosphere. The brewery in Jacksonville does do something similar for their biogas, but it's not as sophisticated. The picture on the left shows their bioenergy recovery system.
Due to regulations being a part of the industry which produces a consumable product, there are regulations needed for formal guidance. Governed by both state and federal laws, breweries must comply with at least 125,000 total regulations. As shown in this figure, the 3 states where each brewery we analyzed are located all fall under the same category of 10,861 to 15,710 state regulations. In addition to these state regulations, there are 115,000 federal regulations. All 3 breweries are operated through Title V air permit, which is under the Clean Air Act Amendment of 1990. These permits allow for proper operation of the facility and validate provisions of control devices under the administrative code based on each state. Shown in the slide are the allowable biogas emission levels stated in each location's Title V permits. The main difference between the 3 is that Merrimack Title did not give specific biogas values, but allowed threshold values instead. By using these calculation-based estimations, it is used to base installations of control devices on the values from the Maricatis Center's RegData database and limit emissions more fittingly.
The broader impact. As mentioned in the background, the brewery industry as a whole generates over 2.1 million jobs and contributes nearly $328.4 billion in economic input. However, there are sizable healthcare costs and environmental impacts from the emissions produced that negatively impact the industry's benefit to the society. And additionally, society as a whole is affected by the air pollutants emitted. They aren't located in specific city types, and additionally, air emissions are spread wide distances. As a result, air pollution from breweries does not disproportionately affect certain populations. More stringent regulations need to be incorporated, as well as regulations should be established for smaller sized breweries, since they rarely have any air pollution control devices.
As for the conclusion, this study analyzed an in-depth process of the Anheuser-Busch Brewing Company. Out of the 8 processes, emission release from PM, CO2, and VOCs are resulted from 3 stages in particular: malting, wort processing, and fermentation. Control technologies are adopted by breweries to limit these airborne pollutants and manage levels of exposure to avoid harmful effects on human and environmental health. Regulations are put on these industrial plants as each brewery operates following a Title V air permit under the Clean Air Act to ensure compliance with its corresponding state and federal regulations. As the beer industry continues to grow, maintenance of emission and release through control devices is needed to handle these target pollutants and reduce atmospheric pollution.